this little capacitor that I made right here, okay, with the 5 field interactions, okay, with the positive and the negative. Okay, I'm connecting my lead lines, okay, for my voltmeter. The red is the positive, okay, the source side, okay, and then the negative is the other. I'm going to connect them and I'm going to show them to you. Okay, this is without the capacitor paper, the parchment paper, anything like that. But you can see this thing change polarity to positive and to negative. Okay. And it starts to go back and forth. Come on now. This isn't that difficult. See how it's flipping and jumping all to different voltages? Okay. You have created a plasmatic effect inside of there, and it's trying to read all of the different plasmatic energy fields that are inside of there. That's why it's jumping around so much. It's trying to read all 7 fields at once, and that's why it jumps. Okay. We did that without wrapping it in parchment paper and aluminum foil. Now, I don't have any parchment paper out here. So let's improvise. I'm gonna go find me a piece of paper or a piece of cloth or something. All right. Go ahead and ask questions, guys, while I'm working, if you want. I'll answer them to the best of my ability. Okay, I'm currently going to make this plasma capacitor using a piece of paper towel, aluminum foil, okay, just a tiny bit, and my activated charcoal. Okay, I'm going to shake it up, make sure it's plenty mixed. Okay. You don't need all of it to be you know, taken care, like completely soaked, but when you use a paper towel, you really don't have much of an option. Okay. What I'm doing here, just putting it in and pulling it back out here. Okay. I'm gonna go get another paper towel to put that one on. Remember, guys, I'm lazy. Okay. I'm also stingy. Not really. It's just something I wanted to say. Okay. As you can see, this has turned black, okay, as the charcoal. If you don't like your fingers, nails to turn black, or, you know, get this ashy feeling, whatever you want to call it, then don't touch it with your hands. Just use gloves. Okay. But this is all that I've done. So now I have a paper towel that has been soaked in activated charcoal and water. Okay. That's all I've done. I'm going to roll this device. I'm measuring is what you guys saw me do here. Okay. Measuring to just about the
Sorry,
same
I'm having a
length.
problem with my video. Mike, look at this. Can you see my video?
I cannot see anybody's
Can you
video at
see
the
this?
moment.
Oh, sorry about that. All right. Thought you could, yeah, you can see it. I
Can't
just
see
have some
anything yet.
charcoal. I got some charcoal here, from burning wood, to cook it.
Okay.
It's like the lightest form of ash you can get.
Yeah, the white stuff is actually cell salts. Okay. Now, what I'm doing is I'm rolling this up. Okay, just like the regular Q capacitors. Nothing special. Somebody calling for me?
No.
Okay. And so all I've done here is just roll this piece of paper towel on top of the plastic tubing. Okay. That's all I've done. Okay. And then I'm going to take this roll and put it on one side. Yeah, I learned this from the IQ guys.
Okay, guys, I have to leave right now. So, Laurie, if you guys can get this uploaded, please, so I can see the end of it, I'd highly appreciate it.
Thank you for joining me and us today.
Thanks. And there's many more to come, right?
Oh, definitely. This is
Okay.
just the first one.
When, how often are you doing it? Every Monday or what?
Yes, every Monday, 8 o'clock, we will have this water meeting.
Okay, great.
And all of the stuff that I teach you today, I basically am going to be giving to you guys as homework to practice,
And get it done.
experiment with,
Right.
and share your results with it, because I'm only one person.
Right, of course. I'm heading to my lab tonight, so.
All right, man. Well, I appreciate it.
I'll have something to show soon.
Thank you.
For sure. Blessings, Mike, and everybody in the room. Love to all.
All right. Namaste.
Namaste.
Blessings to you, my friend.
When I get back, I want to see on your web channel.
I want to see
YouTube
him on there
channel.
too.
Bye.
All right, guys.
All right, great. Bye. Yeah.
When I'm pushing my copper or the aluminum foil down and I'm trying to keep it from sliding off of, being loose, I pinch the very bottom of where I'm starting from, and I just shift everything. So it looks like a little tornado of aluminum foil, and it pinches, okay? And it holds it in place. So now you've got this, okay? And then the other part of it, a little bit longer, is just the paper towel and the plastic tubing, right? In order to take that even further, I'm gonna take this nano-coated wire already, all right? I'm gonna cut off 5 pieces of wire. All right? Doesn't matter how long they are, just how much wire do you want to wrap, okay? The direction of this wire does not matter anymore because we've moved out of the infinity central core of the star design, okay? And we've moved into the outer field interactions designs. 4 and 5. I never throw away anything. Copper. All right, from my memory, and it could be wrong, okay, but just from my memory, okay, is that I will start here on the aluminum foil side, okay? I will put the end of the wire. You don't have to bend any over the ends yet, okay? But I will put the end of the wire right on the edge of the copper wire or the aluminum foil there, okay? And then I will hold it right there and twist it 3 or 4 times. 2, 3, 4. Okay, and then leave the wire up. Okay. You see where I started? Okay. Then I'm going to take another one. This time I'm going to hold it upside down so the wire is pointing down because I want the long wire to be next to the other long wire. All right, and you'll see we're just directing traffic here. Okay, wrap. Doesn't matter if they touch or not. It doesn't matter any of that kind of stuff. Doesn't matter which way, how many turns. You just need to wrap wire on there. Okay, so now I got 2 wrapped around, but they're not touching. There's a space right there in the middle. See if we can get you to the visual. Okay, that's what that looks like. Okay, and I've seen people use 2 of these wires on the aluminum foil to create the battery. You just have to offset it. If you do 3 on one side, you have to do 2 on the other. It can't be perfectly balanced because you want it to create a potential difference. Okay, it's the potential difference that is going to create the energy that you're seeking. Okay? Potential difference just means neodymium GaNs versus hydrogen GaNs. Okay, neodymium is like 60 on the periodic table of elements, and hydrogen is 1. The potential difference between those 2 is 59. So there are 59 energy fields in between neodymium and hydrogen. That's your potential difference, your energy expansion. All right, you want to make that energy move a little bit further. Okay. I'm going to put 4 on the other side because I've got such a long one here. Okay, 1, 2, 3. Okay, nothing special, just wrap them on there. Okay, don't think about it too much. 2, 3, 4. Okay, I don't care that they're off to one side. Don't make this complicated. Okay, the universe is complex, but it certainly is not complicated. Because this one is so long, I'm going to add more, like I said. And then you